Hello everyone, let's continue where we left off. In the last video, we started talking about finding the rule, and we spoke about finding the rule in the situation where we have the gradient and the vertical intercept, or the y-intercept. So these were the two examples we looked at last time. We said, let's say in this example, if I work out that I have a gradient of a half and a y-intercept, a vertical intercept of 1, then I've got my value for m and my value for c, and finding the rule is pretty straightforward. I take those values and I put them where they belong in this format y equals mx plus c. So my half goes here, and my 1 goes here, and I get y equals a half x plus 1. In this video, we're going to continue to speak about finding the rule in a slightly different situation. So this is finding the rule part 2. And we're going to talk about finding the rule in the situation where they give us slightly less information. So instead of giving us the gradient and the y-intercept, this time, in this type of question, we only get given the gradient and one point that the graph passes through. Okay, so in our language that we've built up around, y equals mx plus c, we've been given the value of m, the gradient, and we're also given one point, so one coordinate, which involves an x value and a y value. We're going to look at an example in a second, but first let's just go through the way that I want you to lay out your answers to this. It's very straightforward. We're going to do 4 steps. First up, I'd like you to write the equation y equals mx plus c, substituting in the value that we are given for the gradient in the m position. So the first thing we're going to do is substitute m into y equals mx plus c. So that's the one thing that we do have. So we're just going to chuck it straight in there. Okay. C we don't have, and we need to use this point that we're given to find what it is. To do that, we're going to next substitute values for x and y from the point. So we're going to take this point that we're given, and we're going to say this point lies on the graph, on the line that we're looking for. So if I take that y value and put it into my equation, and take that x value and put it into my equation, then the only thing that I don't know about that graph, that equation, at that point is the c value. And therefore I can, using my skills at solving linear equations, we can solve that. So I've substituted m, then I substitute my values of x and y. Finally, I'm going to solve for c. And then my last step is to rewrite the equation in full. Rewrite the equation in the full format y equals mx plus c, where I leave my y and x as variables now, but now I have values for m and x. In other words, I write the rule that I have found. Okay, let's have a look at an example and follow through those 4 steps. So let's say I'm asked to find the equation of the straight line which passes through the point -1, 2, and has a gradient of 3. So it tells me I've got a gradient of 3, so that is my m value. So my first step is I know my m, so I'm just going to chuck that straight into my equation. So if y equals mx plus c, I know that y equals, in this case, 3x plus c, because the question told me that m was 3. Now I want to substitute my x and y values to help me solve for c. So it gives me a point, negative 1, 2. So that's my x value, that's my y value. Let's substitute those in. So instead of y, I'm going to write a 2 equals, m was 3, x is negative 1, plus c. Okay, so the only variable I have left here is c, therefore I can solve. So let's solve this. 2 equals 3 times negative 1 is negative 3 plus c. I'm going to isolate c by moving the 3 across to the other side by adding 3 to both sides. So c equals 2 plus 3, which equals 5. Okay, so I substituted x and y. This was step C, solving for c. And now we can do step D, which is to rewrite my equation fully. So now I know that my equation, if m is 3 and c is 5, then my y equals mx plus c becomes y equals 3x plus 5. And I've answered the question because I have found the equation of the line with those properties. I just want to, before finishing this, have a quick look at what that means in terms of the graph. So if this is my graph, I'm told that it passes through the point. It passes through the point negative 1, 2, over there, and it has a gradient of 3. That means for every 1 that I move across, I have to move up 3. So I found that if I move across 1 and up 3, I find that I have a y-intercept of 5, which matches up with what we found by doing this little bit of algebra here. So if I join it up, I'm going to get this straight line, and that is the line that I have found. That is the line that matches this equation here. Okay, so just to recap, if I'm given the gradient and 1 point, I'm going to go through these 4 steps, substituting m, then substituting my values of x and y to then solve for c, and then finally writing the equation out in full, just like we did over here.